Hello and welcome to question 21 of this June 2018 calculator paper for GCSE Edexcel Maths. Jackson is trying to find the density in grams per centimetre cube of a block of wood. The block of wood is in the shape of a cuboid. He measures the length in centimetres he measures the length as 13.2 centimetres, correct to the nearest millimetre. The width as 16 centimetres, correct to the nearest millimetre. Height 21.7 centimetres, correct to the nearest millimetre once again. He measures the mass as 1970 grams, correct to the nearest 5 grams. By considering bounds, work out the density of the wood. Give your answer to a suitable degree of accuracy. You must show all your working and give a reason for your final answer. Okay, so by considering bounds, work out the density of the wood. That's our question here. So we need to consider bounds for each of these lengths. We'll also need to consider bounds for this mass, and then we'll also need to consider bounds the density of the wood. So the way I would do this is do length bounds, width bounds, and height bounds. We're going to have our lower bound on the left and our upper bound on the right, because remember, we can't be the upper bound, but we can be greater than or equal to the lower bound, since we always round up. So the length 13.2, correct to the nearest millimetre. So the way I use this to think about the bounds is we have 13.2 correct to the nearest millimetre, so that means we either need to round up to 13.3 or down to 13.1, which would mean, if we were looking on our scale, that if we were 13.25 we would round up to 13.3. Therefore 13.25 is our upper bound. Similarly 13.15 is our lower bound. I'll let you pause and think about this for the width and see what bounds you can come out with. So again, correct to the nearest millimetre, so 16, we either need to be 16.1 or 15.9, which means that we can be 16.05, since if we were 16.05 we'd round that up to 16.1 to the nearest millimetre, or we can be 15.95, since we'd round that up to 16. If you just pause again now and try for the height. So the height's 21.7, so we'd round up to 21.8, or we'd round down to 21.6. So that means our upper bound would be 21.75, since if we were on 21.75 we'd just call that 21.8 to the nearest millimetre. Remember, these are centimetres, this is millimetres, and this is tenths of millimetres. This would mean this would be 21.65. So we have a group of lower bounds for our length, width and height, and we have we have three upper bounds for our length, width and height. So we can work out a lower bound for the volume and a lower bound for the volume as well. So let's do that for our lower bound first. Remember, volume is just length times width times height in any order. So 13.2 15.15 times by 15.95 times by 21.65 equals 4540 point, and because we need a suitable degree of accuracy and there's only 6 numbers past the decimal point, I'll just leave all those in. So 925, 125. So that's our lower bound. I'll do the same for the upper bound. .409 375. So that is our upper bound for volume, and this is our lower bound for volume. We can do the same for our mass now. So we have a mass of 1970. And this is correct to the nearest 5 grams. So this one might give you a bit more to think about with what would be the upper bound and the lower bound. So I'll just give you a minute to pause and have a think about this, and then I'll go through it. Okay, so 1970 to the nearest 5 grams. That means we would either round up to 1975 or round down to 1965, since we're correct to the nearest 5 grams. Which means that if we were 1972.5, we would round up, because we'd be a little over halfway. But if we were 1967.5, we'd round up to 1970. So these are our lower bounds and our upper bounds for our mass. We now need to work out, or we're in a position to answer the question, work out the density of the wood. Remember, density is simply mass divided by volume. And to work out the density of the wood, we need to consider the upper bound for the density and also the lower bound for the density. So the upper bound would be the biggest mass divided by the smallest volume. So that would be upper bound mass divided by the lower bound volume. That would be for our upper bound density. For our lower bound density, we want the smallest number possible, which would be given by the lower bound mass, the smaller number that we can possibly have on the top, divided by the biggest number we can possibly have on the bottom. So let's work those out now. The upper bound we had for the mass was 1972.5, and the lower bound we had for the volume was 4540.925125. I'll just label this to make it clear for the examiner. (1972.5) divided by 4540.925125, 0.3438. So I'm going to take it here. That gives me a nice lot of numbers and it rounds nicely. So 0.434, can't remember the rest, 43438. Our lower bound density, our lower bound mass, I'll do that in red, which was 1967.5, divided by our upper bound volume, which was this, 4625.409375, which gives us 1967.5 divided by 4625.409375, 0.42 537, let's call that. I'm obviously calling this 7 because of this 7 here rounds this up to a 7. Now, we have an upper bound and a lower bound for our density, but we want an answer to a suitable degree of accuracy. Well, at two significant figures, we have 0.43, that 4 would round us down to 0.43, and at two significant figures here, we have 0.42, and this 5 would round us up to 0.43. So that's suitably accurate since they agree. This rounds up, this rounds down, so our answer is 0.43. Correct to two significant figures. Density is given in mass over volume, so that would be 0.43 grams per centimetre cubed. I hope that answers the question. If it's not been clear enough, please leave a comment. If you have any further questions, please leave a comment down below. If that's helped you out, please leave a like. I'd really appreciate that. And thank you very much for watching, and keep up the hard work.